Alright, so today is day 56. What I did was only 3 more lead code problems. I did them in the morning. Probably the last 2 I wasn't able to do them like by myself. I had to rely on the solution. Maybe I should do them again just for practice. Yeah, probably I should do them again. Let's go. Wait. I'm gonna click directly here just to not see the solution. Alright, so the first one is evaluate reverse Polish notation. Maybe I should do them here. Yeah, probably I can do them here. So in this one, the reverse Polish notation, basically, yeah, they give you a string like this and you have to evaluate the expression. And I've realized that in order to solve like this kind of lead code problems, you need to just practice 2 skills. The first one is just be able to match, like to have an abstract solution of the problem. And this is, in my opinion, only pattern recognition. And the second is like concrete way of translating your abstract idea into code. So that's why I think it's just pure repetition, and that's it. Okay, so for this one, I remember the idea. The idea was essentially you use a stack in which you put the like a temporary result, right? And so basically you read the 1, you put it in the stack, then you read the 2, you put it in the stack, then when you encounter an operator, right, you remove the 2 elements of the stack and evaluate the expression. And then you push this result into the stack, and you do this until the end and return the last, like the single element in the stack. So that's basically it. There are 2 ways of doing this. Let me think which one is cleaner. What I did in the morning was I created a dictionary operations in which I say not even a set of operators. So I put here the plus, the minus, the multiplication, and the division. Right, and then the algorithm was, okay, first I gotta initialize also an empty stack. I'm gonna call it the stack, and I gotta say for e in range, I don't think I need the index, so I can say directly for e in tokens, or maybe for token in tokens. It's more explicit. So for every token I'm gonna check first if it's an operator. If it's not an operator, I'm gonna append it in the stack. That's it. So I'm gonna say if token in set operators if it's an operator, I'm gonna pop the last 2 elements of the stack, stack.pop. So I'm gonna say like operand 1. This is gonna be operand 2, and then the result. I mean, the result depends if it's like a multiplication, a sum, a division. So maybe I can create a class which is evaluate expression, that given 2 operands and an operator, it gives like the evaluation. So for this we can use the match operator. I think this is the keyword. So match, and you just put like case. If it's a sum, you return the sum, op1 plus op2, and that's it. So if it's a sum, if it's a multiplication, we multiply. If it's a division, we gotta divide. And it says here in the instructions that it's gonna be, the division is gonna be round to 0, so you gotta put this in order to round it. And some multiplication, division, and this. And what else? So we get a res. The result is gonna evaluate the expression under OP2 and OP1 and operator. Why did I put OP2 and OP1 first? Because the first element that I pop in the stack, for example, I know that I need to evaluate this as a sum. So the first element that I pop is gonna be the 2. And we evaluate first like in the left side, we're gonna have the second element that I pop. That's why. That's essentially why. And what else? So for every token, we check if it's an operator, right? If it's an operator, we pop the 2 elements in the stack of operands, and we evaluate the expression, right? After evaluating the expression, we want to push the value of the result. So it's gonna be stack dot push res. That's it. And if it's not an operator, we're gonna push it to stack also. But we're gonna push the operand, which is token. And in the end, we gotta return the element in the stack, which in theory should be only one element in the stack. I think I can assume that they're gonna give me like a valid sequence. Like an unvalid sequence could be like if you have many operators and not operands, for example, something like this. Okay, let's run it. Okay, there is an error. What is the error? List object has no attribute push. Yeah, it's append. Okay. And what is the problem here? Name operator is not defined. Run. Now the problem is here. Okay, I see the problem. Yeah, in the list we save. We are saving the tokens they give them to us as strings, and we are trying to evaluate the expression that is integer. So we gotta update them. op1 equal to int op1. I don't know if I should evaluate them here. I think not in the function. I think it's more cleaner to do it here. So for token in tokens, if it's an operand, if it's not an operand, we have to do this. And if we want to pass this, we're gonna do it from here, op1. And now this should work. Okay, good. Now let's solve the next one that I did in the morning. The next one I did was daily temperatures. Okay, let's solve it again. So for this one, basically they give you an array of temperatures, and for each day you gotta say how many days you should wait in order to have a higher temperature. So in the first one, if you wait 1 day, you get 38, so you get a higher temperature. But once you have 38, you're gonna wait 1, 2, 3, 4 days in order to get 40, which is higher than 38. And that's it. The intuition to solve this one, it was you gotta have a stack in decreasing order, right? So intuition was yeah, let's call the stack. Yeah, the way I think about it is that, okay, the first thing, which is we're gonna initialize this array of results, which is gonna be like pure zeros, right? And then we say for temp in temperatures, what we're gonna do is that we're gonna have a stack that says we're not like the brute force approach. It's gonna be like for a given day, you check all the next days until you find a day that is warmer. If you don't find it, like you left the zero. Otherwise, like you put it, and you do this like for every day. And that's like not that smart because you are traversing through the next days many times unnecessarily. So one way to fix it is to have a stack in which you delay like the updates of the temperatures. And you say, I'm only gonna update the temperatures if I find a day that is warmer, right? So to be updated, I'm gonna call the stack called like to be updated. And what we do is first we have to check if the temperature that we have in a particular day. So let's say that the stack has the number 30, because in the first iteration we want to save 30 in the stack because it's empty. And then we're gonna take the 38 in the next iteration and ask, is this greater than the last element in the stack? So we ask ourselves if temp is greater than to be updated -1. So if this number is greater than the last element in the stack, we can update the position of this element, right? So we can say res. Also, like another important intuition is that to be updated, we're gonna save the indices. So we're not gonna save the temperatures, but the indices. So in this way, when we update the result array, we can do it immediately, like directly. So I can say that it's gonna be something like, how many days am I gonna wait? Actually, I need the indices now that I think about it. So I'm gonna put for I in range length temperatures, and I'm gonna put temperatures I. So if the current temperature is greater than the last element in the stack, I'm gonna update this and put a 1 here. And the 1 is basically how many days did you wait. So it's the difference between I, which is the current index, minus the index saved in the stack, which is gonna be to be updated. And I think I can put .pop. Yeah. I don't know if this is correct, like if I can do directly this. I don't remember. I think so. All right. So now you know what? Maybe let's do the pop later, just to be sure. So the last element in the stack, the index, we're gonna update that index into this I minus this, and now let's do the pop. So it's gonna be to be updated .pop, and what else? Let's do the other case. The other case is in which the temperature is smaller. So for example, the next iteration, I'm gonna have 38, and it's gonna be if 30 it's smaller. I think you can add it directly in the stack. If it's smaller, it's either if it's smaller or if the stack is empty. Wait, so if the stack is empty, this is gonna be in the first iteration, this is gonna be an error. So I can say if not to be updated, and maybe it's an or. So if the stack is empty or if the temperature is greater. If the stack is not empty. So if the stack is empty, we are just, or the temperature is smaller, we are just gonna add it to the stack. And in the end, we gotta return res. And I think that's it. Okay, there's an issue here. List index out of range. Okay, let's see. So we have for I in range length temperatures, if not updated or temperatures I greater than temperatures I greater than to be updated, res to be updated, the index, I mean it's an index, should be equal to I, it's just a value. So what's the problem? The problem is that to be updated is empty. Wait, if it's not empty, wait, what I want to say, what I want to do, it's like, if it's not empty, I want to do this, so I need an and. I don't know why did I put an or. Wait, what? No. If it's empty, if it's not empty, you can do this. What's the problem? Ah, okay, I got it. But I think this is a problem with the Python version. Probably. Because if there is no element here, then this one shouldn't be a problem. Yeah. So if there's a value, okay, now it works. And what is the output? So if it's not empty, it means that it exists. I can do this, right? Else, and then I pop from the stack. Otherwise, it means that it's smaller. It's either bigger or smaller. If it's smaller, I add the index. There is an error, like probably in these two lines. Let's see. To be updated dot pop. We're gonna have the stack, let's say, okay, let's do it mentally, like very quickly. So it's gonna be, we get the first temperature, which is 30, and then we check if the stack is empty. And given the stack is empty, we're gonna add 0 to the stack. And then in the next iteration, we check 38, right? But now the stack, it has a value. And the temperature, 38, is greater than, I don't know why did I put these temperatures. Yeah, because this is an index. Okay, I mean, there's still be a problem. The temperatures in the stack, if this is greater than this, okay, let's just think about it. So 38, because the index is 1, greater than, to be updated, which is 0, the last element, which is gonna be 0. Temperatures of 0 is 30, 38 is greater than 30, and then it says res of the 0 position, it's gonna be I, which is 1, minus 0, which is 1, and then you pop the value, which had the 0, now it's empty, but now you need to add the value again. Okay, so no matter what happens, you need to add the value. So I think we can remove this, do this, now it should work. Really? If it doesn't enter, if it enters the loop after you finish, you do it, and if it doesn't, you also do it. Okay. So we're gonna go here. It's not gonna enter to this if, the first iteration, then we add the 30, the 0 corresponding to this 30, then 38 greater than 30, the rest in the position 0 is gonna be 1, then we pop the 0, right? But we add the value 1. We add the value 1, right? And then in the next iteration, we get the 30, and then we add this to the stack. So we get 1, 2, but now this is higher. So we should pop 2 from the stack. We're gonna pop 2 from the stack. Yeah, you always do this. You pop it, there is the 1, the 38, and you add this one, the 36. Then you find the 35 and you keep it in the stack. But once you find the 40, you search this one, you update this value. I see. It needs to be, you need like a while loop. Okay, now it works. Yeah, I completely forgot about the while loop, but yeah, it makes sense because you need to traverse like backwards, like the array. Okay, and let's go to the last one, which is car fleet. This one was complicated, to be honest. For me, I remember it took me quite some time. What was the intuition of this one? The main intuition in this problem, I believe, It was essentially you have to decompose it into problems. I mean, okay, no. First, the main intuition is if you have a car that is ahead of you, if the time it takes you to reach the target it's smaller than the car in front of you, you're gonna become a fleet. Yes. Okay, I'm gonna read the problem again. It says there are n cars traveling the same destination on one lane in the highway. You are given two arrays. You are given position and speed. The position I is the position of the ith car, and the speed I is the speed of the ith car. And then you have some destination, which is that position target. So if somebody gives you this position and this the speed of this car, your output is 3. And there is like this notion of car fleet, which is essentially that when a car matches, like gets into the same position at the same time step as another car, they have to, like the faster car, it's gonna go at the speed of the slower car. They're gonna like match speed, and they're gonna be like traveling together. That's like a fleet, and you have to output the number of fleets there are. And the main intuition to solve this problem is, yeah, you sort the array by positions. In this way, you can determine which car goes before and after another. And then you compute how much time does it take one car to arrive to the target. And if the time it takes is smaller, then they are gonna be part of one fleet. It was something like this, right? So first let's start by creating like a list of tuples that they are gonna encode like the car with their speed. Because we're gonna make a sorting, we need to do this. So we can say like cars equals the speed and position for S, P in zip. I think I need to do position first and then speed, because I'm gonna sort by keys, and the keys is gonna be the first element, and I need to sort by position. So it's gonna be zip position, comma speed, and I create the list. And for PS in zip, I think I need to put this into a tuple, otherwise there is like an error. And then for P, S in cars, right? Oh, but cars need to be sorted, right? So let's do sorted cars reverse equal true, because we want to sort in descending order, like from the car that is closest to the end, right? And we also need the stack. What could it be the name of this stack to be representative? Let me think about it. I don't know. Let's call it stack by now. Doesn't matter. All right. So what we do is that we compute the time it takes to reach the target, and this is gonna be obviously the target. We start by this because we know the target is greater than the position, and we divide this by the speed. This is the time it takes to reach the target. And now we have to check if the current car, we have the car sorted, right? For example, here it's gonna be first this car, the car 7, and we gotta check if the time it takes. Okay, but we can start, let's say, at the second iteration. We are gonna check if the time it takes is smaller, if time is smaller than the one in stack. So it's gonna be this stack minus 1. It means that it's gonna be a fleet, right? so we are not gonna do anything. Otherwise, we are gonna append it. So I can put else stack dot append. I'm gonna append the time. Yeah, I think that a stack of times kind of makes sense because we are comparing time. And then we are gonna return in the end the length of the stack. So if the time it takes is smaller than the stack, it means that both of them are a fleet. So we technically don't need to add anything to the stack. Maybe I just put this. If the time is greater, we do the append, like otherwise it will do nothing. But what about if the stack is empty? So I gotta say if stack if the stack is empty, we're gonna add something, and if it's not empty, we can satisfy this condition. Yeah, because if this is true, it's not gonna check this condition. So we can use the OR. Okay, there is a problem. What is the problem? For int and list. I mean, these are integers, position and speed. So target is also integer. And now, what is the problem? List index out of range. Okay, yeah, there's a problem with this condition. So if the stack is empty, okay. If the stack is empty, okay, if a stack, it means that there is something. So I want to say if it's empty, so it's if not stack. Now it makes sense. All right, good. So I successfully redo the 3 problems I did again. And I mean, this is all about practicing, and that's it. So probably I will do them again, but later, once I finish all of them. We are at almost 20 out of 150. So we are at a good pace. All right, that was it for today.